Welcome everyone. Welcome to my channel. So up to now, we have done in this series, we have created a model by creating a sketch using Python, an Inventor API, an Inventor API library, and then we have extruded that sketch in order to form a solid. So if I just run this code, this is what we have so far. We've also set a home view. So the model, basically we're able to see it in an orthographic or in an isometric view as shown here. So now what we're going to be doing is today we're going to be looking at creating 4 holes on each corners here, on all 4 sides, 4 through holes, which is going to go through the solid geometry. So, and then what we're going to do is we basically going to reference it to these, the corners. So how we're going to get the dimensions for that is from the center here. So we know that from the center to this face is 60, correct? Or is it 80? It's 80. Apologies. Let's just check again. Yeah, it's 80. So from the center to here is 80. So the overall dimension should be 160, and then the height should be 60 because from the center to the end is 30 as shown here. So with that in mind, let's start coding again. So if I just close this part without actually saving it. So what we need to do is add holes. So we're going to add like 2.5 millimeter holes, which is going to be 5 millimeters away from the edges. And then what we're going to do is so these are the following steps that we're going to be implementing. So first we're going to create a new sketch with the position for the holes. So we're going to define what work plane we're going to be using. And then second step is going to be, we're going to create an object collection for all these points, or all these hole centers. And then we need to add 4 points as hole centers in this so in this XY coordinate. So basically the first one is going to be, if this is a rectangle, the first one is going to be here, which, and 0 0 is in the middle. So as we know, so it's going to be minus 7.5, and the far end is going to be minus 2.5, and the next one is going to be 7.5, 2.5, and the other one is going to be 7.5 minus 2.5, and the other one is going to be plus 7.5 plus 2.5. So these are the 4 points we're going to be keeping our hole centers. And then finally, once the centers are defined, we're going to add the whole feature to the part component definition. I'll explain as I go along what I'm doing. So first we define the work plane on which it is going to be drawn. So let's create a variable called whole sketch, if I can spell it right. Yeah, and then we know that we have a part component definition, and then within part component definition we have sketches. We're gonna add to the sketches another part component definition. And this is all like we've done it earlier in the previous videos. So for explanation, you can look at that one. Planes, how we find the work planes, the item 3. So we're using the same plane as before that we used to create the sketch for the extrusion. So initial solid. So now we're going to create the hole centers. So we're going to be using the transient geometry as before. So let's create another variable called hole centers this time. And it's going to look at the current Inventor application. So this application, and we need something called transient objects. Just remember, transient means something that changes over the due course of the feature. So if the feature or the part itself changes, the transient object is relative to it, so that changes as well. So we're gonna, there is a method called create object collection, which basically creates an object collection for us to add all these features in. So all the points in, which is going to be in all these points are going to be, these 4 points are going to be in transient geometry, because anything that's related to sketch is going to be in transient geometry. So so it is just created the objects. Now what we need to do is basically we're going to add these 4 points to the hole centers here. So how we're going to do it is basically there is a method called add, very similar to how we did the sketch earlier, guys. So it should be the same. Dot add. So we're going to add the whole sketch, and whole sketch has sketch points. This is another collection, and we're going to add the new whole sketches to the sketch point collection. So call the transient geometry create point. This is another method given by Inventor. Sorry, create point dot 2d. Sorry, create point 2d. That's the method. Apologies. 2d. And this is being a method. It takes argument. So it's going to take the first 2 parameters here as argument. So we need 4 points. So I'll just copy this 4 times. So this is going to be the second point. This is going to be the third point. And this is going to be the fourth point. So now that is done, now we have to add the whole to the part component definition. So as we know, all the features live inside part component definition. So once we created all the features, we have to add it to the part component definition features geometry. And then we know that this is whole features. And then whole features as a method called, in order to drill a hole through it, it's called this here. So if you look at this method, so whole features dot add drill through all extents takes 2 arguments, 1, 2, 3 argument actually. So placement definition. So placement definition is going to be the hole centers. I hope I got this right. Hole centers. Hole centers is what I've written, so we'll just use the same. And then, so we said we're going to be using, is it 2.5 millimeter holes? Yeah, 2.5 millimeter holes. So if we go back to the API help, where is it? Yep, here, API help. So we have diameter as a variant. Variant means we can type it in as a string. So 2.5, we don't have to write it as a centimeter, which is 0.25, which would have written normally. Instead, we can write it as a variant, which means we can type in a string. So 2.5, and we can define the units as a string as well. So Inventor is clever enough to pick it up and set the holes. And then the last one is the part extent direction enum. So we need to know the extension, the direction in which the hole is gonna go through. So we're gonna use the same direction as before, which is 20993, I believe. Correct? 20993 from here. Oh, it's 20994. 20994. Okay. So let's try what happens if you type in 20994. I can't remember which direction it went through last time. So let's run this code and see what happens. Oh, the hole wasn't established because I think we're extruding it in the wrong direction. Or even the sketch hasn't come through for some reason. Am I missing a point here? Create object collection, whole sketch, work planes, item 3. Yeah, I think it's the direction in which we're trying to. Let's change the direction and see. Let's create another part. No, it's not creating the sketch. So what is the only okay, let me just read the code again. This is normal, guys. You just have to keep going through your code again and again and again until you get it right. So transient objects, create object collection. Okay, create. Yeah, so we're creating sketch points. Okay, whole sketch, whole centers dot add. Part component definition features, whole features, all extends. Okay, I'm not sure what's going on. Let's try this again. I've got something commented out. So transient objects. The only thing I can think of is here. If this is not getting added, yeah, there's a typo here. Work instead of work planes, I've just typed in work plane. So we just type in. So yeah, you have to type everything as it is, guys. Otherwise, it's going to be an issue. So let's run this again. Hopefully this time it will come through. Yep, as you can see, it created 4 holes and it's gone through all 4 of them. Yeah. So if we measure it, 2.5 millimeters, probably we can make it 5, can't we? So let's make it 5 mils. Close this without saving, rerun the code again. So creates a sketch, creates a part, creates the whole features, and there you go. Thank you so much, guys. Hopefully you like this video. If you like this video, please do like and subscribe, and I'll see you in the next video. Thank you. And if you need anything else that you want to look at in Inventor, please do go ahead and type in the comment section. Thank you, and I'll see you later. Bye.